Today I'm going to be talking about fractals. Now, fractals are mathematical shapes that are infinitely complex and they exhibit either partially or wholly self-similar properties. This means that a small part of the shape will have a pattern that mirrors and repeats throughout the entire shape. So you can either zoom in or zoom out as much as you want on the shape, but you'll still find that repeating pattern. Now, Benoit Mandelbrot, a Polish-born mathematician, was the first mathematician to coin the term fractal, and he devised an equation and came up with the Mandelbrot set, which looks like this. And he used the equation z of n plus 1 equals z of n squared plus c. Now, Mandelbrot used this equation on the imaginary and real plane. So he plotted imaginary points on the y-axis and real points on the x-axis, and you choose a c point from here to test. So we can go with c equals -1. That is the point we're trying to test to see if it's on the Mandelbrot set. And then we would plug in for all the different z of n values with n equals 1, n equals 2, and so on. And by doing this, the z of n plus 1 value will either converge to one or two numbers, or it will grow infinitely. And if it grows infinitely, then our point C is not on the Mandelbrot set. However, if it converges between one or 2 points, then we know that that point C is on the Mandelbrot set. So the point we chose, C equals -1, its z of n plus 1 values go back and forth between -1 and 0. And because we see this pattern, we know that C equals -1 is on the Mandelbrot set. And that's the Mandelbrot set, one of the most iconic fractal images in the mathematical world. If you have time, I also suggest you look at the Sierpinski triangle, which is another amazing example of a fractal. So, in conclusion, why do we study fractals? Well, beyond their amazing look and beautiful art form like these two here, or the Mandelbrot set that we looked at, fractals also have a lot of practical applications in the modern world. We can use them for AI programming, medical imaging, even tracking the rise and fall of the economy. However, I personally believe that the most amazing thing about fractals is their just beauty of existence. We find them all the time in nature, from clouds to trees to mountains to broccoli, even our lawns. Sharing this mathematical beauty is something that really connects us to nature and shows the universality of math and its uniqueness. Thank you, and I hope you enjoyed watching this video.